after the design. Yeah, and then after the design, we have the construction phase where we actually implement the design that is agreed with the client, and we start with the process on the field. And then the third thing, the main scope of work is maintenance. So the already built structures and plans, we kind of do the repair work and maintenance work, and that's like kind of the big picture of the things. Then in the environment, we deal with the physical and natural built environment, and they include the man-made and the natural environment. For the man-made, we are mainly concerned with the roads, bridges, canals, dams, airports. And for the nature, we usually deal with one of the example can be the soil strength and the slope repair for to protect the buildings from the landslide and those kind of stuff. So going with civil engineering as a discipline, why civil engineering? As a civil engineer, I can say that civil engineering is like everywhere. Let's look at the KAIST as a campus. The first thing when you enter the campus, what do you see when you enter the KAIST? I think the first thing you say is like the KAIST is a beautiful campus, and that's the first thing you notice about its infrastructure, about its building, about its outlook. And that's if you look at the backstory, the people who have worked upon it, you would just end up with civil engineers, the structural engineers who make the designs and come up with these things. So the point is that civil engineering is everywhere. Wherever you go in the world, it's about civil engineering. So basically, civil engineering is the scientific and physical principle application to solve the problems of society. We kind of solve the problems and try to make the human life comfortable by providing different uh, infrastructure and those kind of things. So basically, if you look at it from the academic point of view, it's actually the application of physics and mathematics. And now growingly, the civil engineering is also comprising of computer science, mainly the programming, because field is becoming more interdisciplinarily, and the problems are becoming more complex. The fields are converging together. So it's actually going towards the IT and those stuff that I'm going to explain in the later slides. Okay. The next thing is about civil engineering as profession. So civil engineering can be seen as one of the earliest engineering fields because I think the human civilizations, they developed through civil engineering. So the first things, the shelters and those stuff, the basic human needs were met with advancements in civil engineering. I mean, if you go back to see the past of the civil engineering, we can look at the Egyptian pyramids, Parthenon temples in Greece, Great Wall of China. If you look around all the wonders of the world, you could see that they are all the result of civil engineering marvels. Now, civil engineering education, as it's basically, you go through the same series for all the majors. In civil engineering, you start with the undergraduate degree, you start learning about the basics and the overall look of things. And then if you want to specialize in one of the area of the civil engineering, you have to go through a master's degree. And so far, according to my experience and according to the needs of industry, if you have an undergraduate degree, you could work in the civil engineering in general. But if you want to specialize and become more integrated into the problem solving part of the civil engineering industry, then you have to go with a master's degree. And then PhD is somewhat rare in the industry, but we have a lot of limitations and problems that are being resolved by people through more research, and those people are high-tech or PhD guys. Now, moving on to the different branches of civil engineering. So civil engineering, as I said, is something that you would see everywhere around the world, and that's why it's so widespread. It's almost everywhere, and this can be seen from the civil engineering subdisciplines. So we have coastal engineering as a subdiscipline where you could see civil engineers involved with petroleum and oil drilling structures on the offshores, and we could also there are ports and other structures, marine structures going on where civil engineers are involved. We have construction engineering. That's the sites, or the you could see the rural locations where the development, I mean, whatever that's done on the field is what construction engineering is all about. Once the design is finalized inside the offices, inside the design offices, the construction engineering is that happens to turn that design into a real stuff. So that the process of converting the maps and stuff into the real thing is what it's where the construction engineering is involved. Then we have earthquake engineering. Earthquake engineering is a field of civil engineering where the engineers make an effort to make structures more resilient, more stronger against natural calamities like earthquakes and storms and those kind of stuff. So it's related to the dynamic strength of infrastructure and other structures. Then we have environmental engineering, which is somewhat related to chemical, chemistry, environment, and a lot of policy making and those kind of stuff. This is where the issues of climate change, the renewable and non-renewable fuel resources, and those areas are concerned. And then we have the forensic engineering, the weather and stuff. Then we have below the ground, there is a lot of stuff going on, a lot of application of science and physics. That's where the geotechnical engineering comes in. This is the part of civil engineering that happens under the ground. It's where the foundations of all the structures lie. It's about the strength of the ground for the skyscrapers or the big structures and stuff. So that's where the geotechnical. Then we have material science and engineering, science development and planning. And then there is a field of structural engineering, which from its name is obvious. It deals with the design and construction and planning of structures. Then we have surveying, transportation engineering, municipal water resource engineering. And then finally, we have civil engineering systems, which is a broad area in civil engineering. That's where you could say there's water, sewerage, drainage systems of civil engineering, which is a whole setup of piping in a city or in a country, something like that. So you could call the whole thing as a civil engineering system. Then the question is, in this section, I would like to talk about why civil engineering, its importance, and why the youth is needed in this field, or what's the importance of civil engineering for an individual, for a society, and for a country. So reasons to choose this major, the first one I would pick up is the creativity. So civil engineering, there's a lot of decision making involved in. So on an industrial level, we get problems, we get the demands from the client about something. Let's suppose there is an increase in the population density of a city is increasing, and then this is one of the problem in a city can come up to an engineering company. So the engineering company has to think of the ways how it could reduce that. I mean, what could be done to tackle with the population density. So the solutions could be the efficient transportation system. And now there are a lot of decisions involving what kind of transportation system can come up, what should be the type of transportation, what should be the outlook of transportation solution. So there is a lot of decision making, and that's why engineers have a lot of freedom, a lot of space for thinking, a lot of space for coming up with their idea, their solution to the problems or to the demand. So I believe there's a lot of creativity. Then there's diversity. So as a civil engineer, I think there's a lot of diversity in every phase of civil engineering field. If you look at the from the routine of a civil engineer to its output, there's always dynamic uh, dynamic aspect. From the routine, civil engineer not only has to work inside the office, but he has to go outside to check, to maintain, to see the progress of what he has been doing inside the office. The job location is always on the go. It's always changing around depending on the need. So, I mean, one month an engineer could be working in one city, the other month or the next year he could be working on another project in another city, and then there comes the people. So there is a lot of communication involved in the field of civil engineering, from clients to the consultants to the policymakers to the government. You have to coordinate, you have to communicate about the engineering aspects of projects, about the different aspects of whatever work you're doing, whatever demand you're meeting. Then so this all diversity within the routine, within the job, just makes it an active and on the move kind of career. And then we come to the salary potential. So as a civil engineer in the industry, the engineers usually start as learners, and then as they go up, the project in civil engineering industries are actually very large projects. They could be either simple structures, or they could be the government sponsored infrastructure projects. Usually all of them are pretty big, and at one point of time in the career of engineers, they have to be the one designing the whole thing, working on the whole thing. So there's a whole uh, progress from a learner to a project engineer, or to a director or something. So there's always an increase in the potential, salary potential, and the financial rewards. The other thing about job demand. So civil engineer, as I have mentioned earlier, there's always civil engineering is everywhere, and it's related to the basic human needs. And wherever there is society, there is a need for structure. There is a need for a lot of systems out there, and that's why as the society grows, as the society evolves, the job demands keeps on increasing. The other thing is it's a macroscopic work. So if you look at the other majors that are being offered, you could see that a lot of them are working on minute scale. They're working maybe within the offices all the time, or they're focusing on detail and minute stuff. But if you look at the civil engineers, the products that they're producing, they could be, they're just out there for everyone. So it's a way to change the landscape of the places. And then because an individual is usually known by its work, as we usually say. So whatever you do, it's out there, and that kind of makes civil engineering or civil engineers as the central figures in community development. Now, job prospects and fields. I have tried to put up the cons as well over here to highlight the negative sides as well. So as we know that society keeps growing, keep evolving, the demand for more housing, the demands for more environmental friendly structures keeps on increasing. Uh, there's always the demand for civil engineers. So it's something that's related. Even if all the structures in the world are made, the structure gets getting old, they need to be demolished, new structures needs to be made, the current structures, they need to be repaired, and there is a lot of retrofitting and development of the old structures so that they become more energy efficient. There are new systems involved so that the heating problems and those things are incorporated in the old buildings. So this is a works that the works keep coming, the demand keeps coming. So wherever there's a society, there's always civil engineer. And the other thing is wide range of fields. So as I mentioned, in the subdisciplines, there's a variety and diversity in whatever the civil engineers do. So there are a lot of different and diverse opportunities out there. Now, the cons of the field is that there's a very because the projects are often mega and the projects are directly related to the use of humans. There's always a very small room for errors because even during construction, there's any miscalculation or any error can lead to the fatality and injury of hundreds of workers on site. And then even after the construction and even after whatever the civil engineer is involved in is finished, um, any mishap can take many lives. I mean, even beyond structures, if you look at the water systems of a city or something, if anything goes wrong with that, the whole society stops down. So because the nature of job is such that it's related to the basic needs of humans, there is a very small room for error. Then there's deadlines and obligations because again, it comes that the projects are usually the mega projects. There's always a pressure to get them done from the government, from the city governments, and from the country governments for different reasons. And then the other con is that the projects in civilian, because they're large-scale projects, they are usually very long projects. Some of them can go from 5 to 10 years as well. So, I mean, by working on them, sometimes it can get very monotonous and very long. So, I mean, there could be jobs where the time spent could be smaller, but then there are also jobs and projects which take a lot of time and could be repeated stuff in this industry. And then the final thing is that because these are all mega projects, their volume is quite related to the economy of the country or the area that is in. So if the economy is affected, the construction volume is affected, and then the industry is also affected by it. Next could be the academic prospects. So academically, I think it's pretty much similar for all the other majors. So there's not much here to be explained. So you could go to higher studies, you could have internships, you could have lab opportunities. The same for, I think, all the majors in KAIST. So now from this, I would talk a little bit about KAIST department. How is it different and what are the specifics of it? So according to the vision and goals of KAIST CEE department, there are 6 different areas that they're targeting. If you look at the academics, they are preparing students for all these 6 areas. There's a lot of word courses, and you could see if you go through the research work going on in the department, you can look at that. There's a lot of stuff about smart transportation, where there's a discussion on transportation platforms for driverless automobiles out there. And because of population increase, there is a lot of demand for better and efficient transportation systems. So there is a lot of data analysis. There is a lot of IT stuff getting into the transportation area. And then the second one is resilient systems, because as we can see, as the world is developing, there is more demand. The population is increasing. There is more demand for vertically high structures. There is also demand for aesthetic beauty of structures. So the structures are becoming bigger and taller, and because of that, there's a need for structures to stay strong against all the calamities like the earthquakes. So that's why this area of resilient systems, it focuses on coming up with new ways of making the structures more resilient. There are labs in the department relating with it, like structure analysis lab and dynamics lab and other similar. And then we have the dynamic geotechnology. This is all dealing with the soil and foundations of structure. So it's kind of similarly related to the structural strength as well. Then we have an area of construction robotics. So in KAIST undergraduate, there are a lot of courses related to IT programming and robotics, and also a little bit electrical engineering. So they're all along this vision of the department that construction should be smarter, and there is a more need for tech to come in the civil engineering to make the construction more faster and more safer, and to incorporate the technology in it. And then we have a growing concept of smart green cities around the world, where countries are competing to come up with new plans and new ideas to make the city intact with more technology for the comfort and luxury of population. And that's where the smart green city courses and research work in the department deals with. So there's a lot of Internet of Things programmings. There are a lot of smart devices being developed, and so from the courses to the research work, you could see the focus on smart systems in the green in the city. And then finally, we have sustainable environment. There's a lot of there are many courses from the environmental engineering branch of civil engineering in the department that talk about environmental sustainability in construction as well, and outside the construction as well, in terms of materials and the fuels as well out there. So let's talk about KAIST Department of Civil Engineering. Usually KAIST department is small. The number of students is comparatively smaller in this department, which is a pros and also a con. The pro is that the number of students is lower, so the students to faculty ratio is usually high. That's why you have the students have a more direct relation with the faculty. It's very easy to communicate with them, to catch up with them, to learn from them. So there are many opportunities to get familiar with the faculty and communicate. So I think that was one of a very good thing about my department compared to those of the other departments, where students would literally not be able to catch up with their professors or teacher after the classes, outside the classes. But in civil engineering, you could readily see that it's very easy to reach out to your professor about anything. And then the other thing is, I think this is common in all the departments. So there are department events throughout the year going on. And then there are a lot of outdoor events going on within the department. Students, faculty, they are going out together all the time. So I think because the department is not very big, the connectivity between the students, faculty is, the bonding is quite strong. So you would always come up with some announcements of some activities or outdoor stuff going on. So those were good points. Now, the cons about the small department, I think one of the disadvantages that I realized of a small department was the classes were usually smaller. So I think it makes a little bit competitive environment, because it's I mean, when you think about the grading criteria, you have the less number of students, and then the way the grading and those stuff is decided. So there's a lot of people, there's a less chance of ending up with high grades. And so you have to compete more because of the way the grading system works. Okay, and then the quality of courses within the department. So first thing about the language, as far as I have seen in the civil engineering department, I think most of the courses are in English. I think almost all of the courses are in English, so language is not an issue. And that kind of, and then the PAs are also fluent in English. So I think in terms of language, the department is really good for international students. Then the other thing, I think, in our profession of civil engineering, in our field, uh, along with courses, we really need to be familiar with the field works, with the application of whatever we are doing. So I remember in our courses, there were a lot of field works. So I think that's very good. That's kind of very good to solidify your understanding, and you could literally see outside in the field whatever you're studying inside the department. So I think that's a very good point about the department. And then we have lab experiments. So I think KAIST has a lot of advanced labs out there in the department, which was also a very strong point, because some of the equipment is really hard to find in other universities. So you could experiment and learn from the latest stuff out there in the industry. Then suggested roadmap of courses. So if you look at the way the courses are divided within the undergraduate major of civil engineering and how the research areas are divided, you could put them up into 3 areas, which are structural and geotech area. Then we have environmental engineering track. And then finally, we have the construction ID and urban transportation track. So tracks in KAIST CEE, structural and geotech. In the structure and geotech, industrially, they're mainly focusing on the construction of infrastructure. So you could see the labs working on different aspects of structures, bridges, and dams, especially in the geotechnical engineering labs. In the courses, it could be seen. So if you go by this track, you are going to come across these things within. I mean, if you want a career in these areas in the industry, then this track is for you. And academically, if you want to go into higher studies, into research, so this track, academically and research-wise, you would be focusing on numerical analysis, energy harvesting, advanced materials, underground construction, and geocentrifuge. The next track is environmental engineering track. So in this track, would broadly be studying, learning, and researching about the sustainable environmental processes. So there's a bit of overlap between this department in chemistry and chemical engineering. So you would be learning a lot about the climate issues, the fuel issues, and then when it comes to the latest trends going on, there's a lot of convergence of conventional environmental engineering with nano and biotech and supercomputing. And then the third track within the department is construction ID, urban and transportation track. So you would literally come across labs in the civil engineering about robotics. So I remember in final year of my undergrad, I took a course from the department. I think it was related to construction ID, and we ended up one of our assignment was to build a robot which would just follow some black line on the floor. So I mean, it was very unique part of my degree that as a civil engineers we were designing and we were working on the coding of robots out there in the department. So construction ID is related to integration of robotic technologies with civil engineering and environmental engineering. And then we have urban and architectural engineering for smart and sustainable urban spaces. And then we have smart transportation. One of the other example of this construction ID in civil engineering could be, I think there's some kind of project within the campus where our department developed robots to harvest jellyfishes from the KAIST duck pond. So, I mean, the video could be seen somewhere on the website or in the news. So that is what came out of this civil engineering department and this track. And then the workload description. So I think workload is going to be pretty much similar to what other departments have. Research labs and extracurriculars. I think this is pretty much, I wouldn't go into details into it because the course load, research load, and extracurriculars, this is pretty much similar to all other departments. Okay, finally, once I have covered this civil engineering in general and KAIST civil engineering department, we would have a Q&A after this. But before that, I just wanted to show you, for the people who are looking forward to come into the field and want to know what it looks like working as a civil engineer or as a structural engineer. I think this a bit of, I took some pictures of my project, so I hope you could see what it looks like for a project getting built. I'm actually a structural bridge engineer, and this is one of my projects that I did, that I worked for a year last year, and it's actually a suspension bridge in Turkey. So this is the construction it's not yet completed. The construction process begins with these caissons, which are transported to the boat within the sea, and these are the structures that are designed for the construction workers to work within them inside the water. So these are like the protecting rooms for the construction workers to work under the water for the bridge foundations. You could see them, and then this is where the outcome from the construction work under the surface of the water shows up. This, you can see the tower getting built up. As you can see, there are a lot of structures involved, and there is a steel structure below on the surface of the water, and then there are a lot of cranes and the tower and stuff. So as an engineer, there is a lot of meticulous calculation involved in this. So everything is pretty much on the record in the drawings and always continuously being monitored. So here we have the towers almost completed. And then we have a road that's going to pass through the bridge. And then this is kind of setup, a basic temporary setup for the bridge cables to be erected on. So these are the platform for the workers to work on. So as I mentioned earlier, single miscalculation and a lot of loss, and I mean there's a very small room for error. Then finally we can see cables being erected. And then I think the construction so far has gone till this point where you could see the big cable on the left side of the screens erected. I think the bridge there would be a road segments that would be erected next on after the cables are done. And yeah, that's it for a bit of overview into the project of what it looks like. And yeah, that's it. I think now is the question session. So if you have any questions, please let me know.
Thank you so much, Roger, here for that very informative presentation. So yeah, the people who are here, you can directly ask your questions in the Zoom chat or you can send it through Slido. I will give you like a few minutes to think of questions. But since we're actually very little here, you can actually say it, your, unmute your mic and say it. Oh, we have one question. So it's from Jun Song Kim. He asked, how do you obtain funding for your projects? Does KAIST fund you or do you need to look for investors?
So can you please explain what do you mean by how do you as what? Are you talking about the companies or are you talking about the labs? I mean,
Jun
do you mean
Song Kim, if you can speak.
Yeah, right. So I think the funding usually comes from the projects. I think it doesn't come from the KAIST because a lot of professors are working on different projects within Korea and outside Korea. So the majority of the funding is coming up from the projects, and KAIST might be funding some of the professors or departments in general, but I think this is pretty much a general criteria for all of the departments. I mean, it's not specifically for civil engineering or any department. The funding is majority of funding comes from the projects, from the clients themselves.
Thank you for that answer, Wajahat. So there's another question. They asked, what is the hardest part of doing civil and environmental engineering?
What is the hardest part of civil and environmental engineering? I think so far what I've seen is that when you graduate from university, go to the office and stuff, I think the hardest part is when you join an industry, you just go with your skills of mathematics and physics, and then you are required to get a problem solved. And the hardest part is to make sure that whatever solution you're providing is the safe solution and it's the efficient solution. So I think you have to apply your mathematics, physics, and you literally have to understand uh, how you're applying that to solve the problem. And I mean, to be sure about your solution is the hardest part. Even though you have played with your numbers, you have calculated stuff, but are you sure it's safe? Are you sure it's the most efficient thing? So I think what I've seen is that coming up with the efficient solution and then um, ensuring that it's the safest solution out there for the client, for the people, for the users, is the biggest challenge as a civil engineer. And as you can see, a lot of what we do is we are in direct contact with the people. So whatever we do is directly used by the users, by people, by public in general. And usually it's for the large number of people out there. So you can't, I mean, the small room for error is the hardest thing, I think.
Thank you again for the answer. So we have another question. Um, if I want to take one course just to get a feel of the department, which one should I take?
I think it's a hard question, but I think civil engineering is a very, very broad area. So, and there are many introductory level courses. I remember that in my time, there used to be a course for freshmen. I think it was civil engineering freshman seminar or something, where, and it was supposed to be in English. So I mean, throughout the semester, every day you go, a new professor, one professor would come in every class and in every time there would be different professor, and he would talk about his area, about his lab, and about his branch of the civil engineer. I think if you can get an access to that course, it would be really great to get a big picture of civil engineering. But other than that, if you have if you have special liking for something, then just going up with a basic course in civil engineering, you can get an idea. You could talk to the professors and stuff. So I think any course would be okay as long as it's the basic or the one of the foundation courses.
I'll actually follow up on that. So if ever you guys are interested in environmental engineering, in particular, so there is this one major elective called no, not major elective, I mean basic elective called Introduction to Sustainable Environment and Energy Engineering, and it's taught by Jongin Han. I actually took it last semester, last fall 2020. So that's a good way to get a feel of environmental engineering as a course.
Yeah, and then one thing I would like to add is that I think I remember there are certain courses that could be credit transfer. Like there are people from chemical engineering department who takes a course in environmental engineering within civil, and then that credit is counted towards their major course or something like that. So you could look at the credits to get a maximum benefit out of this thing.
Nice. So we have another question. Can you mention notable URP project topics or research in KAIST that you have come across or been part of that were very successful with practical use? I will send the question to the chat so that you can copy paste the question. I'm so sorry. If the person can send their question in to everyone, that would be great so that our presenter can see it.
I think you can post it, but I think he wants to know about the high potential area in terms of research. Actually, I think this is a very, if you ask about any department, there could be multiple answers to it. And I think my advice would be to go for an area which you like and which you love, because in order for your project or your tasks to be succeeded, you have to get into it. You have to put in the effort out there, and even if that's a high potential area, and you are not giving 100% of yourself, you wouldn't come up with anything out of it. So I think you have to first find out what you are up to, and then look around and see what's high. So I think that's my first thing. And then the second thing, in the civil engineering, I work in the structural health monitoring area, which is kind of trying to figure out the health of the structures by using, like, we used to monitor the structures, the materials, get a data from it, kind of analyze it, and then understand the health of structures. If the structure is getting failing or it's getting weaker, we could get a notice, or we could understand it more and then take care of it before a huge loss happens. So I think in the civil engineering, this is something that we need for our bridges, for our buildings, because it's usually hard to predict which structure or which bridge or which skyscraper is going to fail if a calamity hits it, or if it's getting old. Civil engineering projects are very huge, so it's not an easy thing to just replace them. So better understanding it using technology, data analysis, programming, and then trying to figure out the lifetime or the time of the structure is very vital. And what I've seen is that this area is something that's used in the mechanical engineering, in the aerospace also, for the wind turbines health. And I think wherever there are materials, there are machines. This is SHM is something that that's a hot area. And also I applied to graduate school as well. it was a very high reputed graduate school in US, and I got into the same area. So I think you could just in case you're looking for a high potential area, SHM is a very hot area these days as well. And the second thing is there's a lot of stuff coming in civil engineering, like the robotics, artificial intelligence, programming. These are what people are looking for in the research and in the industry. I mean, the programming is already entering. So AI in civil engineering and then SHM. So I think these could be some of the areas where you could look into it. And then the materials could be another. We're talking about these days, the smart materials. We're talking about, we are trying to come up with concrete. We are trying to make the concrete stronger so that the structures could be lighter and more bigger and taller. So you could look into the smart materials thing also.
Thank you for that answer. Very elaborate. So there's one more question. What is a good minor to go with civil engineering?
Actually, I think again, it's very personal. I think it has to be, it depends on the passions. For me, when I was studying civil engineering, I took BTM as a second major because I think it was very, I just want to share this experience that it was really hard because I was into a lot of extracurriculars, and then the double majors are also there, and then you got, I mean, when you do double major, I think you get one more year within KAIST, so you can use 5 years. But then I wanted to get things done within 4 years. So I went for the second major because I really liked business and whatever concept, whatever things they were talking about in the class. And that's why I was able to finish everything up. So I think major, it really depends on your passion. It depends on your goal, what you want to do. If one of the things in civil engineering is that you could, if you quickly adapt to the industry and learn civil engineering, and you're thinking of starting something in terms of business or anything, then I would recommend going up with BDM or industrial engineering. And but if you're going for research, like in environment or in the ID part, then I think you could just go with something from computer science, or you could go with something from chemical engineering or chemistry if you're going for research in environmental engineering. So you have to you have to do some self-analysis and try to see where you want to end up in the future to figure out what's best for you.
Thank you so much, Wajahat. So we only have 4 more minutes left. So if you guys have like one last question you guys want to ask Wajahat, please send the question on Slido or through the chat in Zoom. I will wait for like 1 minute. And if there are no questions, then we can end the session. Okay, for the last question, I'm sorry if you have to make this a bit quick, Wajahat, but this is the question. Based on your work experience, would you say this field requires a greater focus on meticulous details, calculations, or skills in project management, or good understanding of the larger picture?
Actually, I think what I've seen is that it depends on your goal. If you want to go to the project management side, I think there's no shortcut if you don't have a strong mathematics or physics foundation, because you have to, even if you are in the project management area, you have to know what's going on. You have to ultimately, the purpose of the project is to make sure whatever you're doing is safe for the people, for the public out there. So in order to make sure that everything is safe, you should have an idea of what the calculations are going behind, what's making sure that it's safe. So in order to reach to the point where you are actually overseeing the project, where actually you are managing the projects, you have to go through the calculations, the journey of those calculations and stuff. So I think the way civil engineering starts with, it starts from minute detailed calculations, and then you, as you go progress in your career, you just zoom out from calculations and stuff, and then then you start looking at the bigger picture of things. You manage the big stuff. Unlike the other majors, like where you keep focusing on the minute stuff, minute products, you have to come out to the bigger picture in civil engineering as you progress. So I think it starts with the calculations and then you go for the project management and do stuff.
Great. So actually, I realized we have 15 minutes left before we reach our max 60 minutes. So if you guys have any extra questions, please ask it on Slido or through the chat. I will wait for a few minutes. I actually have a question, Wajahat. Which of the tracks do international students usually go to out of the 3 tracks that civil environmental engineering offers?
Actually, I can't say this because normally there are not many international students, so it's not I can't give figure based on numbers, but what I've seen is that I have seen in structures, and the second one in the IT transportation. I have not seen many in the environment because I think people who want to go into the environment track, they would just simply skip to the chemical engineering stuff if they don't want to work on the environment stuff. When I think the people who are in that area, they are doing chemical engineering or chemistry or do stuff. So I think one of the speakers of KISA, he did transportation or something. I don't know, he was taken Yusuf. So we have an alumni in the transportation track of civil engineering. And then I know people from structures, I think about three people. And environment, I don't know, but there were some of my other batchmates, Koreans, but not internationals.
I see. Thank you. Does any of the, does anyone else have questions for Wajahat? I'll give you like 2 minutes to think, 1 to 2 minutes to think of any questions you might have. So for someone who just came in, we're in our question and answer portion. So if you have any questions regarding the civil and environmental engineering department, you can say your questions through the Zoom chat. Okay, so it doesn't seem like we have any questions right now. I thank everyone for attending this session. Thank you again, Wajahat, our speaker, for being the representative for CEE. We truly appreciate it.
Right, thank you.
Thank you for those who came to the session.
And good luck to the students.